Hello friends, my name is Deepak Goyal. Welcome to our channel. In this video, we will solve the problem next permutation. Let's read the problem and understand carefully. The question says, a permutation of an array of integers is an arrangement of its member into sequence of linear order or linear order. Okay. The next permutation of an array of integer is next lexicographically greater permutation of its integer. More formally, if all the permutation of array are sorted in one container according to their order, lexicographical order, then the next permutation of that array is the permutated that follow it in the sorted container. Okay, okay. So the question says we have given an array that contains integer and we have to return the next permutation. What is next permutation? Means if we arrange all elements of this array in sorted order means in lexicographically order. Lexicographically order means dictionary order, sorted order, increasing order. So then we have to find out the next uh, lexicographical order. So let's suppose we have a number 132. Now we have to find out its next permutation. So how will we find next permutation means we have to find out its next lexicographically order. So to understand first, uh, let's we sort we arrange this element in increasing order: 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, and 3 2 1. This is the all permutations of the number 1 2 3. So 132 is here, and we have to find out its next permutation means we have to return this number 213. And question says if the number is 321 means its next permutation is not possible, then we have to return smallest number means in sorted order 123 if the number is 321. So first approach is first we will find all permutation and store in some vector or in some array. Then we will uh, easily return the next permutation. This is 213. But in this case, time complexity and space complexity will be very high. So we have to come to optimal approach. Let's take another example. In this example, also we have to find out the next permutation. So first approach is first we will find all permutation and will store in some data structures, and we can easily find out then its next permutation. But in that case, the time complexity and space complexity will be very high. So we have to come to optimal approach. So now let's think. We have to return just greater than number, just larger than this. So if I change these two numbers, 10 15, then it will become a next larger number. This if we replace this, then these whole number remain same, and here comes 15, here comes 10, and it will become a next larger number. Let's suppose if this number is 20, then basically we have to find out a number which is smaller than its next number. So here it is 12. So now I have to change in these three numbers, and it will remain same. So if I replace 12 with 15, then it will become 15 20 12. but it is not the next larger number. 15, 12, 20. It is my correct answers. So if I replace 12, 20, 15 with 15, 12, 20, then it will become the next permutation. Let's take another example. Now we have to find out its next permutation. So let's see. If I will change these two numbers 10, 15, let's say if I swap these two numbers 15, 10 to 10, 15, then it will become the smaller element. I have to find out the larger element than this number. I cannot change these two numbers. Uh, let's come to this 21. Now it is also in sorted order, means it is in decreasing order, means this number is greater than this. So I cannot change these numbers. Let's now come to this number 12. Now I can change these 12 number with a larger number. So I can change 12 with just greater than 12, 15. So I can swap. So it will become 15 and it will become 12. Is it just larger number? No. Now I have to sort these number. So these 15, 10, 12, 21, 38, 39, and it will remain same 84, 1, 9. Now it is my just larger number than previous number. So basically what will I have to do? First I will traverse from last and I will find the number which is smaller than its next number. Then if I will find out that number, then I will break my loop. Then I have to find out just greater than that number and I will swap between these two numbers, and then I have to sort the remaining numbers. So this is my intuition. So let's code it. Mm, First I will traverse these elements from the last and I'll find the element which is smaller than its next number. So let's declare size, and size equal to nums dot size for int I equal to size minus 2, I greater than equal to 0, I minus minus. Why I take I equal to size minus 2? Because I have to compare with its next element. So that's why I take this element. I will start from this element 1, from second last element, because I have to compare from its next element. So that's why I start from second last. I equal to size minus 2, I greater than equal to 0, I minus minus. If nums of I smaller than nums of I plus 1, then in that case, I will break my loop. Uh, and I also have to store these index in some variable. Let's define index, int break index equal to minus 1, and break index equal to I. If our break index is minus 1, then it means there is no chance to find out its next permutation. If our break indexes remains minus 1, then in that case we will sort the nums and return it. If break index equal to minus 1, uh, then I will sort nums dot begin nums dot end, and I will return nums. Now come to our next step. In next step, I have to find out the just larger element uh, f- from this break index element, and I have to swap these two numbers. So let's do this. For int I equal to size minus 1, I greater than equal to 0, I minus minus. If nums of I greater than nums of break index, then in that case, I will swap these numbers. Swap nums of I, comma nums of break index. After this, after swapping, I have to sort the remaining number so that it will become the next permutation. Sort nums dot begin plus break index plus 1 to nums dot end, and I will return my number. Return vector nums. Let's run this code. Here is some error. It says if nums of I okay. I do some mistake. Here comes the braces. Let's run again. Accepted. Let's submit. It is accepted. So the time complexity of this code is linear, means O of n approximately, and space complexity is O of 1. In C++, we have a facility to find out next permutation. We have inbuilt function next permutation, so we can easily return this number. So, but in case of Java, we can't use this function. Then we have to use above optimal solution. Okay, thank you.